Moisture is kind of at the root of many of the issues that producers, farmers face inside their poultry houses today. An ounce of prevention is worth a pound of cure. And what we're trying to do is maintain a moisture balance. Whatever they add, we want to remove.
Welcome to Unplucked, the official podcast of the Poultry Science Association. This is the podcast where we strip away the fluff and get real about poultry science from bench to barn. I'm your host, Andy Vance, Executive Director of the Poultry Science Association. In this week's episode, we talk with a friend of mine who's been involved with PSA for a long time, Dr. Brian Fairchild, professor at the University of Georgia and an expert in broiler management. We're going to talk with Dr. Fairchild about everything from air quality and lighting programs to energy conservation and water quality. With his deep experience and expertise in extension and a sharp focus on poultry house environmental management, Dr. Fairchild shares insights that producers and educators alike won't want to miss. Brian's also a past president of the Poultry Science Association and editor-in-chief of the Journal of Applied Poultry Research, so well steeped in the current literature in the research space, specifically as it relates to some of the more applied research and what's happening out in production. Probably spends as much time dealing with growers and people who are actually touching birds as anybody in the association. Brian, thanks for joining us in this episode of Unplugged. Let's start with this area of your specific expertise in broiler management, the house itself, the environment we grow our birds in. What are the most critical factors as you're going and looking at the environment in the broiler house? And how's our understanding of that evolved over the years that you've been working in this area?
That's a good question, Andy. So I think it starts with the house design. You can only work with what you have. And we've made a lot of strides trying to implement new technology, making the houses more efficient. And so with a properly designed house, we can actually achieve a really high level of environmental control where those birds are going to sit in there and it might be 95 degrees outside, but to them, it's going to feel like 70. And so through a combination of air movement and evaporative cooling that's properly managed for that bird age. So we have great strides there. So in terms of where probably our biggest things, the things that I have the most conversations about nowadays is going to probably revolve around moisture control. When we think about it, moisture is kind of at the root of many of the issues that most producers, farmers face inside their poultry houses today. And what we're trying to do is remove the moisture that the birds are adding to the environment inside the house and try to maintain a moisture balance. Whatever they add, we want to remove.
Thinking about how we manage and control that, somebody were asking me for a PSA member who was an expertise on ventilation. The first person I'd think of was Brian Fairchild, because you've built a name for yourself as somebody who really knows how we move air through these houses and working on air quality. I'm going out on a limb and guessing that also has something to do with the moisture that you're talking about, that these issues are all related. You maybe help us connect the dots there on how managing the moisture, and I'm going to maybe think like litter quality, all this is all kind of interrelated with air quality and ventilation. Am I on the right track?
You are. That is a big component of it, would be proper ventilation rates. A lot of people will tend to say it's a big problem more in the winter time or cooler weather months than in the hot months or warmer months. And it's really a year-round task that we're trying to do. And it's really tied to ventilation. In cool weather, it's all about bringing in the air through designated inlets, trying to condition that air. And by that, I mean, we're going to warm it up and elevate that house temperature, that incoming air temperature, so we can hold more moisture. And so when we do that, we're going to pull that moisture out of the house environment, hopefully out of the floor, and exhaust it out. Now, in the hot weather months, it comes down to evaporative cooling from a moisture control standpoint. A lot of people tend to overuse their evaporative cooling. They may turn it on too soon. And most places you aren't going to run your evaporative cooling at 6 a.m. because the outside relative humidity is going to be well over 80%. And all we're doing is saturating the air inside the house. We're not really getting a lot of cooling efficiency of the incoming air. It's a year round process. Now, this time of year, when we have warm afternoons and very cool mornings and maybe cooler temperatures overnight, it gets even more difficult. We tend to see wider swings in the environment between day and night, whereas in wintertime and summertime, they tend to stay more consistent. Again, it's just understanding the principles, making sure we have programmed the environmental controller correctly, and that we are basically trying to ventilate optimally based on the real-time conditions, temperature, humidity outside versus temperature and humidity, what we have inside, and trying to match that up with the right exchange rates.
Thinking about growing up with a small flock of broilers on the home place in our extremely poorly ventilated barns that we had, the first thing I think about when I think about a chicken barn is ammonia, because every time I opened the door, that was the first thing it said hello to me, and it said it very loudly because of how poorly ventilated the buildings were, among other things. But when we're talking about air quality, what are the components of that we need to be mindful of, and how is that engineering you were talking about earlier, the house design, and some of the technologies that we have available to us in air handling, influencing our ability to control the overall quality of the air in the building?
I like to go ahead and get this out as much as possible. We are not using oxygen as a factor in our ventilation rates. So many people are going to say, oh, we got to run more fans to bring in more oxygen for the birds because of their requirements. Honestly, if we do the math and you look at the oxygen requirements of these birds, you could take one of those tiny little fans off the back of your computer, and that would meet the oxygen requirements for those birds, especially for chicks. Now, okay, we got a little older, then okay, take the fan out of your standard oven hood that covers the most stoves to help pull out that steam or that odor to help exhaust that over those in most kitchens. That would probably meet the requirements of older birds. And so we're not talking about a whole lot of large requirements to meet the oxygen demands of our birds. So many people think it's oxygen. They'll say oxygen and pick my battles in those conversations. And we try to educate where we can. CO2 would probably be a more likely component that we would want to ventilate for. Houses have gotten tighter, and in situations where we got really cold weather and we're having to run the heat a lot, the actual heat could actually produce more carbon dioxide than what the birds are doing. And so in those few cases, whenever we got such low ventilation rates, then it's possible that CO2 could dictate our ventilation rate. People will mention carbon monoxide. Okay, well, that's not really a ventilation issue. That is a maintenance issue with the heaters. And so if you try to solve that with ventilation, by ventilating to get rid of the gas that reduce the carbon monoxide concentration, well, the heater's going to run more, producing more carbon monoxide. So we just go back and we want them to focus on maintaining their heaters, and that'll help keep the carbon monoxide in place. And then last, like you mentioned, was the ammonia. And ammonia, if you kind of look at ammonia production, where it comes from, it's coming from the bedding, uric acid in the manures being broken down through a microbial process, bacteria in the litter, and we're getting ammonia production. What's related to all that? Moisture. So it's very difficult to ventilate for ammonia, because if you have an ammonia problem, and let's just say we're sitting at 40 ppm and we want to get it down to 20, we have to double the ventilation rates. And so in order to get it cut in half, you're essentially going to have to double that ventilation rate. And even if you do increase your ventilation rate and you turn the fans on and off, the minute you turn the fans off, that ammonia starts to rebuild. It's always being generated from the litter. And so we want to make sure that we try to prevent it as much as possible. And one of the ways to do that's through good moisture control. I know I sound like a broken record, but you want to attack the problem. And the problem in that situation isn't the ammonia. The ammonia is a symptom of the problem. The problem was the moisture.
Well, what that says to me, as you mentioned, that it becomes really clear how interrelated all of the pieces of the house environment are. If you move one lever over here, it's probably affected two or three other metrics that you might be tracking for whatever reason, which the other thing I was thinking about as you're talking through that, when the heater example with the carbon monoxide, you're going to run the heaters more, you're going to create more carbon monoxide. You're also spending a lot more on your energy bills then, which is something I thought about as you were talking about the evaporative coolers. Well, you're not going to run them at 6 in the morning because you're just going to move a bunch of moist air around. You're also wasting a lot of electricity. So let's talk about that aspect of broiler house management for a minute. Energy conservation, certainly a concern, both in terms of, environmental sustainability, which the industry is trying to work more and more on all the time, but also cost. If I want to be an efficient production system, I need to think about my energy costs. Are there strategies, technologies, things that you're seeing from really effective commercial farms that we need to talk about or that are worth sharing with the audience today?
Sure. So I'm going to back up for just a second because, again, like you said, all these things are connected. So, yes, you could be running your heaters more, you're creating more carbon monoxide, you're burning more gas. And so, one of the other things to keep in mind during cooler weather, 80% of our heating costs is related to ventilation. If we are trying to control ammonia by increasing our ventilation rates, and let's say we double our ventilation rate in cold weather, that could lead to almost a doubling of our energy usage as well from on the gas side. Because most of the brooder systems that we're using, the heating systems in these houses are using natural gas or propane. And so they're all kind of related. In terms of energy conservation, from a moisture control point, just kind of tie all this together, an ounce of prevention is worth a pound of cure. That's really important here as well, applicable that we could be much more economical to prevent and maintain that moisture balance than it will be to try to ventilate for problems like ammonia and others later on. From a management standpoint, trying to ventilate properly and be preventative is going to help a lot on energy usage. In terms of technology that's coming out, we're constantly looking at new innovations that are being developed in various parts of our industry. We do continue to test new heating systems that we're looking at. Circulation fans are a good way of taking that air that we've already heated up and it's up at the ceiling because hot air rises. But that circulation fan system helps move that air around, break up the vertical stratification, but it also moves the air from the warmer parts of the house to the cooler parts of the house. And so again, it all depends on your degree of leakage in the houses and what kind of heating system you have. But there's typically a fuel savings and energy savings from using circulation fans. And I think a more developing technology that we're going to be getting into in the future, it's out there, it's available. It's just a matter of implementation and learning how to incorporate it into the poultry houses, both new housing as well as getting it as a retrofit into our older housing as well. And that's going to be variable speed fans because we could lower the RPMs of that fan and we'll move less air, but we also use a lot less power in doing so. So it's actually cheaper to run two fans on a lower RPM than it is to run one fan at the higher RPM. And so that's another thing that's coming and is developing. A lot of people are looking into it. We have probably 3 or 4 farms ourselves that we've retrofitted with variable speed fans and are looking at how to implement this, testing it, seeing the pros and cons. A lot of it's just getting the systems together to help control those fans in a manner that people can operate easily.
Well, and I don't want to overlook, because we've talked a lot about air quality, air movement, ventilation, moisture control, but we know lighting is an important part of the management, the growth of broilers, animal welfare. Certainly, that's a piece of that puzzle as well. As the lighting programs and technologies have become more sophisticated, what's the latest research you're seeing or that you're interested in about how light impacts broiler growth and welfare, and how good a job we're doing of implementing that research into your average broiler house?
From an energy conservation standpoint, most of houses have adopted the LED technology. They have been really a big success in cutting down some energy usage in a lot of poultry houses. The big thing I see nowadays is try to get people to choose the right bulbs. And what's happened is all this transition happened It's somewhere about, I got to get back into my calendars and look this up to be a little bit more accurate on this, but let's just say it was 8 to 10 years ago. Maybe it was 10 or 12 years ago. I'm not exactly sure. I have to really sit down and figure that out. But what we're starting to see is a lot of those initial bulbs that went in, they have such a long lifespan and they don't really fail. And so they just get lumen depreciation over time, whether they're getting dirty or whether it's internally through the internal engineering of the bulbs. But we do see some lights deteriorate over time. And so most people don't replace them until they fail completely. And when they do replace them nowadays, they're going out and they're picking a bulb. They may even buy the same bulb from the same manufacturer, but that's not the same bulb they have in their houses. And so you go in there and you start looking, and not only do you have differences in light intensity, maybe differences in spectrum output, there might be some differences in the internal engineering of that bulb that affects how many milliamps that's being pulled on those bulbs, which then ties back into the dimmer. And so we'd like to see linear dimming of these bulbs inside the houses. And instead, what we get is sometimes more of a quadratic curve to that. Right now, where you've seen this transition right here, where a lot of bulbs are probably going to have to be replaced. And so there's no really guidelines on when to replace an LED bulb because, like I said, they go forever. And then when they do fail, you've got to replace them. But it might be several years, and the technology changes so fast in that area. So what we got to do is provide some guidance to people, hopefully backed up by sound research, and make some research-based recommendations to help make sure that when they do buy new bulbs, that we're getting the most return on our investment.
The other piece of this kind of triangle I'm thinking of in terms of management: air, lighting, water quality. I don't want to say is maybe the most important, but certainly I've heard it said water is the most important nutrient. So let's talk about water quality and consumption so we don't overlook that. For you and your research, and as you're dealing with producers and advising them on their facilities, what are the top things we need to do to make sure that water is helping rather than hindering the performance of our birds?
Well, first, make sure we got the right volume of water that we can deliver the peak demands of water usage inside the house. And that's going to be big birds, probably near market age. Their big peak demands going to be in the mornings when the lights come on. Everybody's going to go get breakfast and they're going to eat some food. They're going to drink some water. And there's just this big peak demand on the system. And so worst case scenario would be older birds with the evaporative cooling system running. And so we got to have so many gallons per minute. The water usage by the bird's fairly consistent and it's fairly easy to calculate. It's the evaporative cooling demand, that peak demand. Now it changes a little bit because it's dependent on inside outside temperatures, inside outside relative humidity, the air exchange that we're doing, how many CFM are we actually pulling through the house at a maximum point. And so we just want to make sure the whole water system is sized correctly to deliver the right volume to the house. I'd say the next big things come into place when it comes to water is water quality. And again, a lot of research, a lot of focus, a lot of times is on, hey, how does water quality affect the bird? And we've done some work ourselves. There's quite a bit of work in the literature. And when you look at it, there's certain aspects of water that can result in loose droppings, maybe even some diarrhea in the birds. And obviously we want to try to maintain that water quality as good as we can. The birds do not need the exact same water quality. Would I love to provide them the same water that I'm drinking, either out of the bottle or from the water fountain down the hall? Oh, sure, I'd love to. But sometimes you don't get a return on investment for putting in the treatment system to get that water to that quality. It doesn't manifest itself in bird health or bird performance. What I've found is that it affects the equipment before it affects the birds. And so you'll end up with leaky drinkers. I was just on a farm about a week ago, and they had a tray system under the drinker. And so it was catching any drips. Well, that tray was absolutely full. And it wasn't every single drinker in the house. It was just a few here and there. And it was leaking. I sat there and I watched it drip every 4 seconds. Imagine that happening with 1,000 nipples inside of the house. That's quite a bit of water going on there. And so we want to make sure our water quality is good enough that we're not affecting our drinker system. Another thing, we just talked about guidelines for replacing light bulbs. I would say that the guidelines aren't very clear on when to replace the drinkers. They do wear out. They don't last forever. And you got all these birds, you go in there and just tapping away at the trigger pins. It wears them out over time.
Right.
And so what a lot of people will do is they'll just replace the drinker as they see leakage. Well, the problem is you never have a new drinker system. It's always kind of this normal distribution, right? You got some old, you got some that are midlife, and then you got some that are brand new. And you never have a new system. And so you're just constantly doing this exchange. So when do you replace the whole nib? That's some information that we need to think about in the future and what kind of guidance could be provided to people. And the last thing would probably be the management of the system while the birds are there in the house. We've got to make sure we maintain the proper height relative to bird age and bird size. And usually we want those birds just reaching up just slightly to trigger that pin and get their water. We don't want them to have to bend down, and we don't want them to be able to sit down and drink, because that ends up with a lot of water going onto the floors. And then there's the water pressure. There are guidelines. Most of the manufacturers have got these guidelines that say, hey, at this age, we'd like to see a water pressure of this with a water height of this. There's some good research that was done years ago out of the University of Arkansas that compared 6 different drinker systems in the same house. And they basically saw no differences in bird performance when the drinkers were ran according to the manufacturer guidelines. They did see some differences in litter quality, but that gets back to some of the drinker designs that they tested. Some of them were high flow drinkers, others were low flow. But it was an interesting study just to show, hey, we can get normal bird performance, optimal bird performance, just by following those drinker manufacturers' guidelines on operation. That's kind of the whole thing tied back into that whole moisture control theme. What we've really been trying to promote over the last 10 years. We put a lot of emphasis on that.
Well, that's important. And along those lines, as we've been having this conversation together over the last 20 minutes or so, you've mentioned some technologies, the lighting technologies, some of the things we were able to do in ventilation. As you've evaluated new technologies, both in your role as an extension professional, but then also as somebody who reads an awful lot of literature as editor-in-chief of the Journal of Applied Poultry Research, are there more recent innovations or things that you think that are still coming into the fore now that you think have real staying power, the power to, maybe they're not widely adopted yet or they're coming down the line, but you think, hey man, this is really going to move the ball forward if more people will use this or do this or learn about this? Are you seeing any research that's got you excited now on the technology front?
Well, technologies, it could be a broad word, right?
Yeah, absolutely. Especially in this space, right? We could be talking about everything from nuts and bolts to data.
Exactly. And so when you were asking the question, the first thing that's going through my mind is, of course, looking at the house, thinking of ways to make that more efficient and reduced costs, reduced labor at the farm level. And there's some new stuff coming along that, we've already talked about the variable speed fans. I think that's definitely going to be something of interest in the future. There will be some of the work that we've been doing here recently is we've been looking at plastic pads for evaporative cooling systems. Traditionally, they've all been paper in the past. And you get into some parts, depending, we have a few places here in Georgia. There's other states that have got some water quality issues, and that shortens the life of those evaporative cooling pads. And it's a fairly large expense for the farm to replace those pads every 4 to 5 years. And so you'd like to see those pads last 10 to 15 years or longer.
Sure.
And so we finally have gotten to where there's some good options out there. We actually started testing plastic pads here probably 12 years ago. And they did fine. Just they can cool very similar to the paper pads, but there are unique things that are distinct to each system, paper pad system versus a plastic pad system. And we've got a few newsletters out on that. We're starting to get more interest in going out and delivering some of our work through presentations at various meetings on this new concept coming out, because I really do think that's going to help out several farms that are struggling with water quality, because these pads, not only do they not break down because of the poor water quality and fall out of the system because they get so soft and just basically disintegrate, but these plastic pads, we can actually clean them better. We can use a high pressure wash to break that stuff off and clean it. Can't do that on a paper pad.
Right.
Carve your name in it when you're doing it with that type of system.
Yeah.
So that's two examples.
Mhm.
Yes, there's a lot of work being done on the more computer tech side of things, I'm going to say, data driven side, where I'm going to use the term big data, where we're collecting a lot of this data coming in. And I think there are opportunities there. Again, this is stuff that we probably were looking at, I don't know, 18, 20 years ago with some of the companies. The big things at the time is that, yeah, we collected all this data, but we needed a way to kind of pull it together. And now we have the cloud, a lot of cloud based services that are doing this. But then it comes time to develop the programming to be able to recognize, hey, this is normal, this is different. And getting that into the whole process is kind of where we're at right now, and probably see future opportunities. Of course, I'm constantly always thinking about the farm. How do I make growers more profitable? They're more profitable and do well than the companies do well. And we keep chicken and egg prices at a minimum. But there's also the animal welfare component too that can be brought into this from some of the technology that's coming down to identify problems sooner rather than later.
You've got me thinking as you talk about big data, how do we turn that into practical tools, applications, insights, actionable information for the producers? I also heard you in there talking about your newsletters and the presentations that you give and all the communication that you do with industry. So I want you to talk us through your approach as an extension professional who's also really steeped in the literature because one, you're just somebody who's really knowledgeable about the literature, but two, because of your role as editor in chief of the journal. How do you approach, or how do you recommend others approach the process of translating research data into practical tools or management practices in the field? What's that look like in the Fairchild mindset paradigm approach?
Well, I think there's probably more than one way to do it, but I'm going to tell you kind of how we approach it. We may start off with some work inside the university research farm here where we are looking at some new technology, maybe some new methodology. We might look at that a little bit just to make sure that, hey, this is doing what we think it's going to do. If we see something promising, we're going to take it out and we're going to actually do field tests. And it gets hard because you lose a lot of control over things when you step outside and start working with a farm somewhere, and you just never know what's going to happen. I'll give you an example. One of our recent field tests, we were looking at lighting programs, first week lighting programs. We was doing it on a 4-house farm, had 2 houses that were treatment, 2 houses that were control. We were going to repeat it for a minimum of 3 flocks. Now you can't plan these things, but all 3 flocks had a little bit of an issue with inclusion body hepatitis, which affected the bird livability a little bit. And so that is a risk you take when you go to the field. But again, our test was, in our opinion, it came out to be successful. We got data that we needed. It was done underneath real commercial type conditions that are in business to sell broiler meat. And that's the way we do it. And then we turn that into a paper. It was published this year in Journal of Applied Poultry Research. And then from that, we'll generate 2 or 3 newsletters that may end up obviously on our website. But again, they get picked up by various popular press and online media sources to help distribute that information to people who can use it and utilize it.
So now I want to shift back and go the other direction. So we talked about how you go from research data out to the industry. Let's take it back the other way. Because of your role in extension, as I said at the top of the program, you probably talk with more producers than anybody I interact with on a regular basis. And this is your chance maybe to talk to your colleagues in academia as much as anything. What are some of the common questions or challenges you hear from industry and the producer specifically through your extension work that you'd like to share back with the rest of the PSA community who may or may not have those same opportunities to interact with the production system that you do?
Andy, we don't have enough time to cover all that. But anyway, when they're talking to me, they're kind of saying, hey, we know what your background is. We know what kind of work you do. A lot of the problems I hear are kind of they fall underneath my umbrella. It's things that I can address with. But if we want to talk generic, there's a lot of questions out there when it comes to management for optimal bird health. And I think you said it very well earlier in our discussion here about how all of these things are related.
Yeah.
Once we get outside that optimal range and that bird gets some kind of challenge, I'm going to call it a stress because the house is too hot or it's too cold or air quality isn't right, that could open that bird up to some health issues. It may compromise the immune system, and we end up with higher probability of that bird getting infected with something, a virus or bacteria. All of these things come together, but a lot of times I'm seeing a routine concern about bird health. And a lot of times we don't really know why that one flock that we were talked about earlier, where we were doing the lighting study, we spent a lot of time ago, company did. We talked back and forth trying to figure out the farmer. There's a lot of discussions going on. Why in the world was there 3 flocks in a row that hit this particular farm? And it's just, we don't know. Biosecurity was good. Management was good. It's just one of those things that is that ongoing question. I had another phone call recently. It was somebody who was kind of in the sales side, and they got a client, and it was a farm. And they said, well, we want to get our litter tested for pathogens. Can we do that? And I'm like, well, we can do it, but it's going to cost a lot without knowing what we're looking for, So, I mean, there's a lot of people that want the answers to this stuff and try to do better.
Right.
I think that is overall theme that we're seeing. And then the next one is going to be costs.
Yes.
Everything's going up. Inflation wise, when you think of propane, natural gas costs, electricity costs, bedding material or cleaning out and replacing the bedding material periodically in our poultry houses, feed costs. I mean, all of this stuff continues to increase, and it's a concern on trying to how to be efficient enough to be able to stay in business and make a profit without causing our chicken prices to go significantly higher at the grocery store. We don't want to be paying $10 a pound.
All right.
Chicken.
Right. It's a challenge. Brian Fairchild, what a great conversation. And I would just say to folks listening, if you want to know how to manage a broiler house, call Dr. Fairchild. If you want to know how to put together an exceptional extension program, call Brian Fairchild. What a great resource, and grateful to you for your leadership as a longtime member of our board of directors, but also as our editor-in-chief of the Journal of Applied Poultry Research. Friends, if you have enjoyed this conversation, I would highly encourage you to make sure that you have subscribed to Unplucked. Give us a rating wherever you listen to your podcast. We're here each week with an expert like Dr. Fairchild, sharing some of the latest science, research, and information of interest to the poultry industry. Next week, a couple of things I want to have on your calendar. We are about ready to start the PSA Pacific Rim Scientific Conference. If you're coming to Macau for that inaugural event, I'll look forward to seeing you there. If you're not, stay tuned, because of course you can later on read some of the proceedings. The articles will come out in a journal like the Journal of Applied Poultry Research or our other journals, Poultry Science and European Poultry Science. We'll have some articles from the symposia there and a lot of other information on our social media channels and our website, poultryscience.org. That's next week in Macau. Also next week, Tuesday, you can still register for this one. Our latest PSA webinar is going to talk about one of these technologies that is changing the world as we know it, artificial intelligence. We're going to talk specifically about AI in the college classroom, some of the opportunities and obstacles. We have a couple of experts going to tackle that. 2 of our leading experts in teaching as members of the Poultry Science Association, Dr. Liz Karcher, the newly named Associate Dean for Undergraduate Education at Penn State's College of Agriculture, and Dr. Jason Emmert, Professor of Animal Sciences at the University of Illinois, 2 really bright teaching scholars. They'll be joining us next Tuesday. That's at 1 o'clock Eastern. You can register for the webinar at poultryscience.org. This episode was produced by Lindsay Johnston with editing and engineering by Michael Lunt of Parasol. For the Poultry Science Association, I'm Andy Vance. See you next week.